Hello all. Welcome to a presentation of my book, Interconnectedness of Life. As you can see, the title is connected with these lines of words. The soil ecosystem as the taproot, the earth, an ordered web of life, perceived by mystics, proved by science. This means that in addition to other scientific proof, a research in the soil ecosystem revealed that the soil ecosystem is the taproot of the interconnectedness of life. And the interconnectedness of life is like a web of life on the whole earth. Also, for thousands of years, without any scientific tool, but with his mystical insight, man already perceived the existence of the interconnectedness of life and the importance in his physical and spiritual well-being. As a result, he developed his culture and the rituals and practiced these in preservation of the system. These are going to be dealt with step by step in this presentation. After this, it will be apparent that a neglect of the system can be a reason for most of the social, political, spiritual, health, and ecological problems we have today. The presentation consists of two parts. The first part is the scientific revelation of the interconnectedness of life. The second part is man's mystical perception of the system. I now start with the first part. But first of all, what is the interconnectedness of life? It is a way in which all life forms live in an interdependent manner. For example, say that there is a food producer, but he doesn't have water to cook his food, and so will go hungry. And there is a water supplier, but he doesn't have food, and so we also go hungry. So both of them agree to help each other. The food producer supplies food to the water supplier, and in return, the water supplier supplies water to the food producer. So they live in an interdependent manner in which the existence of one depends on the existence of the other. So this is a similar thing between plants and animals. All life forms need energy for their existence, but not all of them can afford it. The only ones that can produce the energy are the plants. They do this through a process known as photosynthesis. That is, they use light energy, carbon dioxide, and water to produce oxygen and the glucose as the source of energy for life. The animals, including man, eat the glucose by eating the plants. They also breathe in the oxygen. In the animals, through a process known as respiration, the oxygen reacts with the glucose. In the reaction, the glucose and the oxygen are changed back to the carbon dioxide, water, and the energy. The animals then use the energy and breathe out the carbon dioxide. But the plants need the carbon dioxide in the photosynthesis, so they take it and use it in producing the glucose and the oxygen again. In this way, the plants and animals live in an interdependent way in which the life of one means the life of the other. The plants supply food and oxygen to animals, and the animals in return supply carbon dioxide to the plants. In addition to the carbon dioxide, the plants receive other things from the animals. For example, some groups of soil organisms feed on organic matter, and through this, they release mineral nutrients from the matter. making the nutrients available to the plants. One of the groups of the organisms is the oribatid mice group in the British soil. Some other organisms pollinate the plants, thereby facilitating the plant's reproduction. Some other groups disperse the plant seeds, making sure that the plants don't grow in one place. This ensures the plant's survival because they are growing in one place would result in a competition among themselves for mineral nutrients, light, and water. Now, for the existence of the whole system, each group of the organism should not overcarry out or undercarry out its own activity. For this reason, each group has its specific population value, which should not change. That is, the population of each of the groups should not rise above or fall below its own specific value. Rising above the value means overactivity of the group, and falling below the value means underactivity of the group. The natural controllers, including the predators, are the main forces that ensure that the population values don't change. If the populations of the organisms increase above their specific values, the natural controllers intensify their controlling activities. For example, the predators intensify their predatory activity and so bring the populations down to their usual values. On the other hand, if the populations decrease below their normal values, the controllers relax their controlling activities, leading to a rise of the population to their normal values. The natural controllers also have their own specific population value, which is regulated by other factors. Now, not only that the organisms interrelate, we are going to see that their population values are in delicate balance with each other, and an upset of the balance leads to a change in the normal rate of the activities of the organisms. This brings us to our research in the British soil, where this was identified. The research was under the auspices of the Department of Pure and Applied Biology, University of Leeds, in the United Kingdom. In the research, we investigated the effect of pesticides on the pests in permanent grassland, that is, grassland with intact soil ecosystem. We found out that in the plots with the pesticides, grass yield was higher than in the plots without the chemicals. One might conclude that the reason is because the pesticides killed the pests in the plots with the pesticides and so saved the grass. But this is not the reason. We found out that there was no significant difference in pest population between the plots with the pesticides and the plots without them. So this remained a mystery. It was during the period that a mystical event occurred, directing us to look for the reason in the grassland soil ecosystem. The details of the mystical events are in the book. We looked for the reason in the soil ecosystem and found it. The reason is because there are groups of organisms in the soil, each with its specific population value, which is in delicate balance with one another. Among the groups is the oribatid mice group, the group that specializes in releasing mineral nutrients from organic matter, making the nutrients available to the plants. Also, in the soil are the natural controllers, which control the populations of these groups of organisms, preventing the populations from rising above their usual values. In addition, there is a competition for space and the food resources among the organisms, whose populations are being controlled. Through the competition, a pressure arises. The pressure contributes to preventing the populations of the organisms from rising above their usual values. So, what the pesticide did was that they selectively reduced the populations of the soil organisms without having significant effect on the Uribatid mites. So, this means that the mice were no longer facing any pressure that prevented their populations from rising above the usual value. Consequently, the mice population increased above usual. The mice role in the system is to release mineral nutrients from organic matter. The increase in the population led to an increase in the plant's mineral nutrients. The end result was the increase in the grass yield. Let us have a look at our data. In the table is the control plot. That is a plot without a pesticide in it. In the plot, the population of the Uribatid mice is 13.1 per soil sample. The population of another group, mesostigmatic mites, the predators, is 16 per soil sample. The population of another group, Colembola and the minority groups, is 57.1 per soil sample. And the grass yield here is 2.587 tons per hectare. Now compare this to a plot with the pesticide, propiconazole, and see the changes that took place. The pesticide reduced the population of the Colembola and the minority groups from 57.1 down to 36.7 per soil sample. The population of the mesostigmatic mites was reduced from 16 down to 9.1 per soil sample. Consequently, the population of the Uribatid mice rose from 13.1 to 25.4 per soil sample. Following this, the grass yield increased from 2.587 to 2.78 tons per hectare. The same information can be seen in this bar chart. The dark color represents the control plot. The gray color represents the plot with the chemical propiconazole. Compared to the control, the chemical remarkably reduced the population of the Colembola and the minority groups. See the decrease. It reduced the population of the mesostigmatic mites. As a result of the reduction, the Uribatid mice population remarkably rose above the usual level in the system. See the extent of the population increase, how it is higher than the population in the control. The end result was the increase in the grass yield in this plot with the chemical. This reveals that in the interrelationship, a change in one group of organisms does not occur in isolation, but occurs as a result of changes in the other groups. For example, the increased grass yield is because of the increased population of the Uribatid mites, following the reduction of the populations of the other groups of the organisms. Awareness of this does not only enable us to give the reason behind an increase in grass yield, it also enabled us to develop an index for predicting a change in grass yield following an upset of the population balance of the soil organisms. For example, the increased grass yield above the usual level is because of an increase of the proportion or percentage of the Uribatid mice in the population of the whole soil organisms. This means that where the mice percentage is high, the grass yield will be high, and where the percentage is low, the grass yield will be low. That is, following an upset of the population balance, the mice percentage correlates with grass yield. Let us have a look at the graphs of our data. See the graph showing the correlation of the grass yield with the percentage of the uribatid mice. In the y-axis is the grass yield in tons per hectare. In the x-axis is the percentage of the uribatid mice in the population of the whole soil organisms. See the curve showing the grass yield increasing as the uribatid mice percentage increases. The experiment was repeated in a different year and the correlation repeated. See the graph of the data and see the grass yield increasing as the percentage of the uribatid mice increases. So from this, it can be seen that the uribatid mice percentage in the population of the whole soil organisms is a valid index for predicting if grass yield will be high or low following an upset of the population balance. The tables of the data and the more details of how the index was developed are in the book. This finding indicates that the soil ecosystem is the taproot of the interconnectedness of life. That is, as the plants provide the energy that supports the life of animals, the soil organisms in the soil ecosystem provide the mineral nutrients that support the plant's life. Now, we are going to see that interconnectedness of life is not restricted to the land, but also extends to the sea. Let us have a look at this. Just as plants on the land produce energy for animals on the land, microscopic plants known as phytoplankton produce energy for the animals in the sea. When present in high enough numbers, some of the phytoplankton can be seen as a colored patches on the water surface. Just like other plants, they produce the energy through photosynthesis. By feeding on the phytoplankton, the sea animals gain the energy. Like other plants, the phytoplankton need mineral nutrients. Some of the mineral nutrients come from the land. The seabirds play an important role in this. The birds have their nests in the trees on the land, but they depend on the sea for their food. They fly to the sea and feed on the small fish in the sea. Because they feed on the fish, their droppings are rich fertilizer. That is, their droppings are a source of plants' mineral nutrients. So, the droppings contribute to enrichment of the soil with the plant's mineral nutrients. When the rain comes, it washes some of the mineral nutrients into the sea, thereby making the nutrients available to the phytoplankton. It can be seen that the seabirds play two roles here. First, by feeding on the small fish that graze on the phytoplankton, the birds take away excess fish that may lead to overgrazing of the phytoplankton. So by feeding on the fish, the birds contribute to controlling the population of the fish in the sea. Secondly, through feeding on the fish, they help in the process of converting the fish into mineral nutrients for maintenance of the phytoplankton. So, the seabirds depend on the fish as the source of their energy, and the phytoplankton, which sustain the fish, in turn, depend on the seabirds and the land for provision of their mineral nutrients. So even though the sea is separated from the land, the life on the land and the life in the sea are interconnected in such a way that the well-being of one depends on the well-being of the other. These are just an overview of the interconnectedness of life. If we go deeper, we will see the interrelationship of plants and the plants. and the interrelationship of animals and animals. This finding reveals that a model of interconnectedness of life can be a route to a solution of many problems. During the time I was preparing to write the book, I met a friend, Andy, an English young man, a postgraduate student at the University of Leeds. I told him about the book. Shortly after this, I got a letter from him. In the letter was a quote of the authors whose work was in agreement with our research. Here is the quote. Monocultural models of biological evolution have given way to conceptual frameworks that recognize that species often co-evolve in ways which make it impossible to understand the changes in one species without considering simultaneous change in the other species. We will think and teach more effectively if telecommunications and the society are viewed as a co-evolving complex of process. Telecommunications, societies, economies, governments, human aspirations and human values shape each other in much the way complexes of living organisms evolved in interaction with each other, each being cause as well as effects of the other's change. Collapsing space and the time. Geographical aspects of communications and information. 1991. Brun S. Limbach T. Page 46. This is the end of part 1 of the presentation. We are about to move to the part 2. Meanwhile, if you need a copy of the book in any format, visit my website, www.mosaicmusic.co.uk. That is www.mosaicmusic.co.uk. You can also get a copy of the DVD on this presentation by visiting the website. The presentation is also available in PDF. Also, this knowledge inspired me to compose and produce music. The name of the music is Give Them What They Need. That is, give all creation what they need. If you do, you will gain your own chance to live. To get a CD of the music and my other music, visit the website. Thank you all.